Hi, my name is Paul Colgrove, and in this fifth video we'll be looking at our latest development, which is ColWeld Sense. And when you're manufacturing parts, you'll find that not all parts are the same. There are a whole range of reasons for that. First of all, it can be your cutting process, it can be your bending process, it can also be, particularly on a part like this, it can be distortion, and the operator can even put the part in the wrong position. So as a result of all those variability, you're not going to get the welds exactly where you want them unless you do some kind of sensing. So in the example of this part here, we found that due to a combination of probably bending and distortion, this weld here has a variability of about 5 millimeters. And so it's essential that we have some kind of sensing. Now, the ColWeld Sense node that we've developed with the software actually has 4 different options. So with this part here, you need to identify your main sensing direction. And in this case, the main direction of variability is in this direction here. So our first point, which we will define, will go here. And as you can see from our ColWeld Sense node, we need to identify the direction. We will also identify our start point. Now, the second main area of variability is with the twist of the part. And so to measure that, we need to measure another point in the same direction, but further down the part. And so we identify that we're measuring in the twist direction, and we will put our start point there as well. It can also vary in the transverse direction, and we call that perpendicular in the software. And so we will put a third point around the back, and the angle of that is 90 degrees. Now, when we go from this second point to the third point, we've got a possibility of it hitting the component. And so what I'll do is add a preliminary point to avoid that. And then the final direction is the height of the component. In this case, if we just go vertically downwards, we will be hitting the wire, and we don't want that. We want something that's not going to change. And so you can see that in all these points, we're actually using the shroud to measure the component. And so what I've done there is I put the torch on an angle, and we're going to measure it with the side of the shroud. I'll also add a preliminary point just to make sure we don't have any collisions. Okay, so we've now done our sensing node, and all that we now need to do is to program our weld. We put our first point in, add our second point. We are now ready to run the software, and in the first time it runs through, it will be running in calibration mode. Calibration mode is very important because you're measuring the base part. All the subsequent parts are referenced relative to this. So you can see that it's now measured those 4 points. It will then go and do the weld, and of course this weld goes exactly where you did the original program. Now, once it's run through for the first time, it stops. You then stop the program, and it automatically transfers to measuring mode. Okay? So what happens there is the next time you run it, it's actually measuring those same points, and then this weld is changed according to the new position. So to simulate that, what we will do is move the part slightly in by about 6 millimeters here, and I think I've put about a 4 millimeter spacer in the transverse direction. So we will now rerun the program. Okay, sensing the first point, second point, Third point. Also measuring the height. And now we can see that that weld has gone exactly where we want it to go. Thank you.